7 and 9. So radical 9 times radical 7, which simplifies to be 3 radical 7. All right, that should be review for you. If you struggle with that, then we need to practice. However, let's get down to D. What did I do when there was a fraction here, radical 4 over 5? What happens with the radical and the fraction? It breaks up. So we have radical 4 over radical 5. And what does that simplify to be? 2 over radical 5. And that is your final answer. But here's the thing. We didn't really deal with fractions or radicals in the denominator earlier this year because we didn't need to. But there's a thing that you might have learned in geometry class, and if you didn't, that's okay, but typically in math world, we do not like radicals in the bottom of a fraction, which is called the denominator. So it says you should have learned that there's a convention that we do not like radicals in the denominator of a fraction. So to solve this problem, and this will come back again in pre-calculus and calculus, to solve this problem, you're going to do a process called rationalizing the denominator. What does rational mean? When we think about rational, what does that mean? Like a number. What's a rational number? Like 4, okay. Is our square roots, like radical 2, is that rational? No, it's irrational. We want to turn numbers that are irrational into rational numbers. Huh? You want to go home?
Yeah, because denominator sounds like a Cubic and nader on it.
Oh, okay. I'll take your word for it. It's true. I've never watched that show.
What?
I don't have a TV. We've gone over this. All right. Now, let's talk about how to rationalize this. I have our original fraction, radical 4 over 5. And what we did is the first thing is we need to simplify this fraction that we started with. We already did that, and we said that that was equal to 2 over radical 5. So you simplify the fraction as much as you can to start. Secondly, we need to multiply this fraction by a fancy 1. A fancy form of 1. Now what this means is, let's think about what happens when you multiply by 1. Does multiplying by 1 change the value of the number? No. So what we're going to do is we're going to keep the value of this fraction the same. We're just going to make it look different. So the fancy 1 that we're going to multiply by is radical 5 over radical 5. All right, you take the denominator with the radical. You just take the radical part and you turn it into a number 1. And now what we're going to do is we're going to multiply straight across that fraction. So the numerator is going to be 2 times radical 5, which is 2 radical 5 here. And what's radical 5 times radical 5? Radical 25. Well, let's simplify again. What's radical 25? 5. So this is really 2 radical 5 over 5. That is the final answer. That is the rationalized version of 2 over radical 5. And they are actually equal in value. So 4 over 5. So these 3 are all the same. They just all look different. Yeah?
So I don't know if you're gonna get to it, but
We don't like radicals in the denominator. So that's how we got the radical out of the denominator. Was we rewrote the fraction.
yeah, but the first one was just 2 over 1. The first, like the 4/5 doesn't have 1 in the denominator.
It has radical 5 in the denominator.
She's talking about the first one. Like radical 4 over 5.
Yes, it does have a radical in the denominator. It's radical 4 over radical 5. It's the same problem we did up here.
Sorry.
It's okay. All right, so let's move on. Let's try it again. So just stick with us here. Let's go through these. As we go through the next couple, we're going to find a pattern so that we can make this faster. What do I have to multiply by here to rationalize this?
3.
Radical 3 over radical 3. So we're going to multiply both the numerator and the denominator by radical 3. Okay, guys, can we focus a little bit here? I know it's Friday. So we multiply straight across. And what does your numerator become when you multiply? 2 radical 3 over radical 9. And what's radical 9? 3. So this is 2 radical 3 over 3. You'll probably start to see a pattern here in a minute, but we'll talk about it after the next two. All right, so the equivalent form is 2 radical 3 over 3. Hold on, just let us go. You're okay. Now the next thing is 1 over radical 8. I want to start by simplifying radical 8 before we move on. What perfect square goes into radical 8? 4. So this is 1 over radical 4 times radical 2. And what does that equal? 1 over 2 radical 2. Which you can do in your head if you want. What do I multiply by to rationalize that?
2 over 2.
What? Just square. We just deal with the square root part. So just radical 2 over radical 2. Bless you. So we're going to rationalize by multiplying by the square root that's in the denominator. Now let's multiply across. 1 times radical 2 is just radical 2. Down on the denominator, that 2 stays there. 2. And radical 2 times radical 2 is radical 4. I know this is the long way, but we'll see the pattern in a second. Well, what's the square root of 4? 2. So this is really 2 times 2, which is 4. So the answer is radical 2 over 4. That's the answer, 4. This is equal to 2 right here. So you have 2 times 2, which gives you 4.
What if you multiply by radical 8?
That's fine. You would still end up with the same thing. You would just have to simplify later on. Okay. Why don't we do a C? Let's first simplify here. Rewrite this as radical 16 over radical 7. Which, what does that become when you simplify it? 4 over radical 7. What do I multiply to rationalize here? Yes, radical 7 over radical 7. So then I multiply straight across, and then we'll develop our pattern here. 4 radical 7 in the numerator. And radical 7 times radical 7 is radical 49.
7.
Which is just 7. Well, what pattern are you starting to notice about the denominators here?
It's the same thing.
Yeah, the denominator of our final answer when we're rationalized is equal to the radicand that you started with, right? So the radicand is the number under the radical. So let's write that down. The denominator is equal to the radicand. So if you remember that rule, it saves you a little bit of work and a little bit of space. So when I go ahead and do D here, what would I rationalize? What do I multiply by? Radical 3 over radical 3, just the denominator. Well, what does the numerator become? Radical 5 times radical 3 is radical 15. And what's my numerator using this trick? Denominator, I'm sorry. Just 3. Because it's radical 9, and radical 9 simplifies to be 3.
Oh.
Does that make sense with the trick there? Why can I not simplify the 15 and 3? Because this one's not under a radical, so you can't square root or simplify it. Yes?
So what about B when it's 8 and it ends up being 4?
But I can't simplify it here because the 2's under the radical.
It's not 8. So how do you know when you're...
Okay, so good question. Good question. Let's talk about that. If I rewrote, let me go down here. So if I start with 1 over radical 8. So yeah, Grace is right. If I did not simplify from the beginning, and I just did that, I would get radical 8 over 8. But I still have to break down this radical 8, right? Because I have to simplify my square roots. Which is 2 radical 2 over 8, which still breaks down to be radical 2 over 4. So really what we did, now let's go back to that trick here. What I really did here, I simplified the original, right here. So since I'm multiplying by radical 2 over radical 2, I could have done a shortcut. Instead of writing 2 times radical 4, and written 2 times 2. Still gives me 4. Still works. Don't worry. Just go with it. Just, you'll be fine. So let's look at the bottom. What if I have 3 over 4 plus radical 7? Very bottom here. If I were to rationalize this, what fancy 1 should I multiply by? If I were to rationalize that, what should I multiply by? What have we been doing? What's our pattern? Radical 7 over radical 7. All right, so that's what we think we're going to work. So let's see. That looks like it's going to be yucky, but we can do it anyways. I have 3 over 4 plus radical 7, and we said we're going to multiply it, bless you, by radical 7 over radical 7. So let's see what happens. When I multiply across the numerator, I have 3 times radical 7, which is 3 radical 7. Now we need to be careful in the denominator. I'm taking this entire left side times radical 7. So that's really taking 4 times radical 7. 4 radical 7. And what's radical 7 times radical 7? Plus 7. Uh-oh, did that do what we wanted? No, it did not get rid of the square root in the denominator. So, sad face, no, it didn't work. Uh-oh, we have a problem. Although all is not lost because there is actually a way to do this. It's just a little more complicated. So flip your paper over. Let's figure out how it's going to work. The reason that did not work is because in order to simplify these, we actually have to use something called a conjugate. And we're going to use conjugates throughout the rest of the year. But a conjugate is something like these examples right here. X plus 2 and x minus 2. 3 plus I and 3 minus I. For our example, 4 minus radical 7 and 4 plus radical 7. What do you notice about all those conjugates? Different signs. Same terms, different signs. Okay? So we're going to work on the last one. 4 minus radical 7 and 4 plus radical 7 because that is the denominator that we had on that previous problem. So we're going to end up figuring out how to simplify. So let's multiply 4 minus radical 7 and 4 plus radical 7. All right, so let's write them out this way. And I'm writing them that way because how am I going to have to multiply these together? I'm going to FOIL, distribute here. So let's see, if I take 4 times 4, 16. 4 times radical 7 is plus 4 radical 7. Negative radical 7 times 4 is minus 4 radical 7. Well, that looks like it's going to be helpful. And then I have a negative times a positive, so I'm going to have a minus. What did we just talk about if I have radical 7 times radical 7? It's just minus 7 on the end. Now here's the good thing. What happens in the middle? Cancels. So I really only have 16 minus 7, which is 9. That looks a lot nicer than what we had. No, that's not the whole answer. That's what the conjugates multiplied together are. So let's see what that does when we put it into our problem. So right underneath, you don't have to flip anywhere. Let's look right under. 3 over 4 plus radical 7. So what I'm going to do when I rationalize these is you need to multiply by the conjugate. So what is the conjugate of 4 plus radical 7? 4 minus radical 7. So you'll multiply by 4 minus radical 7 over 4 minus radical 7. Now the numerator is exactly like what we did on the front. You take 3 times 4, which is 12, and 3 times negative radical 7 is minus 3 radical 7. Now we just did this. We just took these two terms right up above, multiplied together, and what did they simplify to be? 9. So now here, it's not always going to work, but does this simplify anymore? What goes into all of those? A 3. So 3 goes into 12 4 times. Then I would subtract and get minus 1 radical 7 over 3. That is your final answer. That's it. So let's try that a couple more times. But before we try it 2 more times, we're almost done. Let's take the conjugates here. What's the conjugate of 6x minus 4? Yes, 6x plus 4. What about 8 plus 2i? 8 minus 2i.
Question.
5 minus 5 plus 17? Yes?
What's I again?
Oh, we're going to talk about that in just a minute. So I'm gonna hold you in suspense. We're going to do an I in a second. Conjugate of a minus b? A plus b. Alright, so let's use this conjugate 2 more times. Let's get the hang of it here. We'll do another with a radical, then we'll bring I back in. So I have 2 over 1 minus radical 6. Now in order to rationalize again, I need the conjugate. So what's going to be the conjugate of the denominator? 1 plus radical 6. Alright, so to rationalize here, you take the original fraction, 2 over 1 minus radical 6, and you multiply it by the conjugate over itself, which is a fancy 1. And you are going to very carefully multiply everything together. So what we get here, I'm going to take 2 times 1, which is 2, and 2 times radical 6. Now the denominator, I suggest, if you need to, put them in parentheses so that you're careful when you multiply together, that you're not just adding or anything. You start with 1 times 1, which is 1. 1 times radical 6, which is plus radical 6. Minus radical 6 here. And what's negative radical 6 times positive radical 6? Minus 6. All right, well, as usual, this is always going to happen. The middle terms cancel off. So you end up with the same numerator over what's 1 minus 6? Negative 5. Who came up with that rule? It's not radical, it's okay. You can have a negative, yeah. That's not a rule. The radical is a rule. Negatives are not a math rule. Yes. Can you simplify radical 6? No, so then you're not. Okay? Do you see how to do this one? All right, last one. Let's bring I back into it. We'll answer Andrew's question. 7 over 4 plus I. What's the conjugate of 4 plus I? All right, so 4 minus I. So same process here. I start by multiplying my original fraction by its conjugate over the conjugate. Now, when you multiply these together, you'll have 7 times 4, 28. 7 times negative I is minus 7i. And we're going to really carefully multiply the denominator. Okay. 4 times 4 is 16. 4 times negative I minus 4i plus 4i. And then here's the part where we have to talk about I again. Okay, that's what we're going to talk about. What is, well, I times I will be I squared, right? So I times I right here is going to be I squared. What is I? It is imaginary, but what number is it other than I? What does it represent? The square root of negative 1. So when I have I squared, that's really the square root of negative 1 squared. But what happens when you have a square root that's squared? It cancels each other. So what does that simplify to be? Negative 1. So I put a minus 1 on the end. Always. I squared is equal to negative 1. We just never multiplied i's before, so we didn't have to worry about it.
15.
Well, now it is going to be. So the inside crosses off, and you get 28 minus 7i over 16 minus 1, 15. Nothing simplifies, so that's your final answer. We good? We understand?